Vertical Future are a technology and data company. We were founded in 2016. We started as operators. We learned a lot from operating. We learned a lot from operating other people's systems. We learned a lot from where the bottlenecks were, what was going wrong with those systems, what was going right with those systems. And what we've done is we've turned that into a specialist company where we develop, deploy, and then continuously support through a data network vertical farming systems. So our hardware solutions are proprietary, they're in-house, and they're designed to change the rules of crop production. And the critical part that we're looking at here when we're looking at the rules of crop production are when we're looking at the price. We're looking at achieving price parity with current production methods. You know, the Green Revolution was transformational on agricultural productivity through breeding. We're now in the second wave of the Green Revolution where those varieties are being incorporated with new technology developments, and that technology development is now really sort of impactful. And those innovations need to go through to achieving price parity with current methods. We need more food. We don't need more expensive food. And the price parity is predicated on good system design and good system operation. And so when we look at the first one, system design, we've worked in-house to do this. We have full end-to-end automation. So we have automated seeding all the way through to automated harvesting. That at no point during that process, from when the seed is deposited on the substrate through to when the substrate and the crop goes through to harvest, does a person have to be involved with that crop. And that allows maintenance of much higher quality standards as well during the crop production process. We've also got through this end-to-end integration. You're able to eliminate the operational bottlenecks that I spoke of around sort of that we'd learnt from our own operational experience. And what that has allowed is improvement of operational efficiency. And again, when we're looking at price parity, we need to be making these operational efficiencies in order to get there. We've also, at Vertical Future, invested in our manufacturing facility, which is just north of London. And as the video said, we are deploying the same model worldwide in key geographies to make sure that our supply chains are shorter. So alluding back to the previous session where we're looking at sustainability and carbon impact, we don't want to be shipping things too far around the world. So we have about approximately 90% of our equipment is manufactured in-house. When we're looking at the commercialization and that sort of pathway to profitability, this again enables much greater efficiencies to be realized as by sort of decomplexifying the supply chain, having fewer partners involved in that supply chain means that you have fewer dependencies. It means fewer people are taking a cut of profits, which means that you can pass those savings in terms of capital and that capital deployment onto the producer who is then producing that crop eventually. And from an operational perspective as well, this means that every operator has a single point of contact in Vertical Future in order to access any sort of support, any spares, any maintenance, and that continuous data development. But the asset alone isn't the end of the innovation journey, and as a scientist who specializes in production of data related to plant growing, this is very much where I come in. And it's much like buying a computer. You buy a computer, you get continuous software updates. You buy a vertical farm asset. That asset is designed to last for multiple decades. It's not a flash in the pan. It's not something that you can replace every 5 to 10 years, dependent on new innovations that are coming out. What you want to do is you want to have your asset that can incorporate those new innovations into it. And the data is what is providing that opportunity to improve and continuously improve the operation and the operational efficiency of your asset. Our systems are also incredibly flexible. So I didn't mention, like as an example, our lighting. We have five-channel spectrum lighting. And within that, there's over 10 billion combinations of spectra that you can deliver to plants. Many of those will probably be absolutely useless to plants. You probably don't want to give 100% green light to a plant. But you could do if you wanted to. But what that allows is that level of flexibility of the system, which means that operators can pivot dependent on the needs of the market. So whether that's what crops look like, so whether you're looking at creating, for example, a more sort of pigment, like a higher pigment producing lettuce, or whether you want to completely switch into a different market. You want to start producing crops for biopharmaceuticals, or you want to produce crops as a nursery stage rather than full through to commercial sale. And all this data that I've been talking about is all delivered through Diana, which is our software as a service platform. Diana essentially provides automation, space allocation, plant libraries, and plant recipes. And when we put them all together, we look at those as being plant algorithms. And as some examples, some of the algorithms that we've developed, we have lighting-related algorithms that improve energy conversion to biomass by 24% when you compare it to a baseline lighting recipe. We have nutrient delivery and water recycling programs within it, which enable you to have a much greater recycling of your water and greater recycling capability of the nutrients within that water as well. And we also have air circulation programs, and those air circulation programs allow you to maximize the vapor pressure deficit required to support high levels of photosynthesis. And you bring those three activities together, you can tailor those during the life cycle of a plant, you can tailor them during an individual day, and then you can make sure that at every point during a 24-hour period, the plant is getting its optimum conditions and turning the energy that you're putting in into the maximum biomass conversion that you're getting out. So when we were talking about this session with Mark a few weeks ago, he asked me to touch on how vertical of future investment in R&D is expanding the marketplace of vertical farming technology deployment. So here we're looking at how we can use science, how we can use research and innovation to broaden the scope of avenues that we can look down as commercialization opportunities. And I've got two very, very different examples to give you. So the first is still in plants, but it's in using plants for downstream processing. And this is looking at using vertical farms to produce material for the alternative protein market. So many people who are involved in vertical farming or even glasshouse growing will have heard of amaranth. Amaranth in vertical farms is typically associated with a microgreen, which is used as a garnish. It's very, very sort of light in flavour, incredibly high in antioxidants. It's also very high in protein. It's traditionally grown in Southern Africa and South America. In Southern Africa, it's grown as a leaf crop, so much like spinach. In South America, it's more like a quinoa grain type crop. And it's been grown and cultivated for more than 8,000 years, and there's a huge variety of different seed accessions available through the World Vegetable Centre. So we've partnered with academics at the University of York, at the James Hutton Institute, at Crop Health and Protection, which is one of the UK agri-tech centres. We've also partnered with a major UK retailer and an alternative plant protein brand to develop and demonstrate the case for using this protein within both ready-to-eat and processed foods. So the graph to one side shows the essential amino acids and the quality of amaranth when you compare that with soy protein and pea protein, which are typically the alternative proteins used when you're looking at meat replacement or protein enhancement in many processed products. Soy and pea are generally deficient or lower in the essential amino acids described by the Food and Agricultural Organization. When you look at amaranth, which is the blue bars, it hits the 100% line for all the essential amino acids that we need in our diet. And that hits it for both adults and for children. And that's pretty unique amongst plant proteins. So this is one of the main reasons we started looking at amaranth as a sort of an alternative protein for that market, because it provides a real genuine alternative to meat and dairy proteins. And then when we looked at how you could grow it, because amaranth is typically grown in very warm conditions, not very UK-like, we looked at growing it in glass houses and we looked at in vertical farms. And we found that through our optimized growing parameters, we were able to achieve 40% protein when you look at the dry mass of the leaf, compared to approximately 25% when you grow it in a glass house. So there's a real opportunity to be gained by growing in a really, truly controlled environment of the vertical farm. And finally, I'm going out of this world. I'd like to talk about the space agri-market. Much of the technology that we use in indoor agriculture has roots in space, with NASA particularly leading the charge in activities like LEDs on facilities in the ISS, including in their systems called VEGI and the Advanced Plant Habitat, which is pictured above me. However, to date, all growth in space of plants has been experimental, and it's been carried out in a facility approximately the size of a large filing cabinet drawer. So it's not enough to feed the crew who live up there. And as human exploration moves further from Earth, self-sufficiency is going to be more important. Again, linking back to the last slot about sustainability, resupplying to low Earth orbit has an incredible carbon footprint. Sending up seeds on one resupply and then leaving them up there is a much better use of your carbon, a much better use of your energy, a much better use of your payload space. So self-sufficiency is going to be important. Resupply is going to be further and further apart the further away we get from Earth. And plants are more than just food, right? They can be used for biomanufacturing. You can use plants to produce pharmaceuticals. You can use plants to produce plastics. All of this is going to be incredibly important the further we get from Earth. You also have a very limited crew size in space, which means that all of this growing needs to be autonomous. It needs to be self-regulated. There needs to be a lot of control within the system that's able to monitor and regulate itself. For example, Axiom Station, which is the first commercial space station, which is due to go free from the ISS by 2030, that will have a permanent crew of 4. And you can't expect Matt Damon to be part of that crew. You haven't necessarily got a botanist on board. So you need to make sure that these systems self-regulate, but also that there's communication with Earth so that they can then be regulated by experts sitting on the ground here. So we've partnered with the UK Space Agency and other partners from commercial space exploration, which includes Axiom Space, who are developing the first commercial space station. And our work within this project is to get our first demo facility on the ISS. Our aim for that is by 2025. We'll then upscale the installation and we'll put a biomanufacturing unit in the biomanufacturing node of the Axiom station. That will be by 2030. But our ambitions don't stop at low Earth orbit. We're looking at the Lunar Gateway, we're looking at the Moon, and from the Moon we're actually looking at Mars as well. So the activities that we're doing within this project and this particular piece of work, they will impact not just on Earth, but beyond. But all of the learnings that we're getting from this, all of the improved robustness of the facilities, this will all impact massively on the on-Earth market, which again has that nice sort of route into your commercialization. You have almost bomb-proof facilities, because to put something on a space station, it needs to be incredibly robust and incredibly resilient. So with that, I'd like to thank you all for listening, and I will hand over to Helen.